Welcome to this video on prompt engineering as a real discipline. We'll explore 6 key techniques, review live before and after demonstrations, and identify the compounding habit that brings them all together. This is the real version. This is episode 23 of the Mastering AI ML, brought to you by the Series of Thoughts team and Technovative AI. Some think prompt engineering is just about typing nicely, or that better models will make it obsolete. Both views are incorrect. It is actually a structured, essential discipline that yields significantly better results from the same underlying model when applied correctly. What defines a real discipline? It requires techniques, measurable outcomes, and transferable patterns. Prompt engineering meets all three, allowing you to control accuracy, format, and depth by refining how you structure your prompts. It is important to understand how models process information. Your prompt input is the only context the model has. If your input is vague, the model fills in the gaps with its own assumptions, which may not align with your goals. In this video, we will cover 6 core techniques to master your results: specificity, few-shot examples, chain of thought prompting, persona assignment, structured formatting, and iterative refinement. Our first technique is applying specificity and constraints. The core issue is that vague prompts produce vague, generic answers. We need to be intentional. Compare these 2 examples. A weak prompt asks for a report summary, while a strong prompt defines the audience, specific constraints, and what to exclude. The strong prompt removes ambiguity and steers the model toward your exact need. To build a constrained prompt, consider these 4 pillars. Identify your audience, set clear length constraints, define your desired output format, and specify the tone required for your specific output. Technique 2 is using few-shot examples. Simply put, pattern matching beats a long, wordy description every time. Providing 2 to 3 input-output pairs activates the model's pattern matching capabilities. This is far more effective than trying to explain every detail, as the model can infer your desired structure and tone from your examples. Here is a comparison. Describing the classification logic leaves room for misinterpretation. Showing it with specific examples demonstrates your required format and logic immediately, removing all ambiguity for the model. Technique 3 is chain of thought prompting. The strategy here is simple. Always reason before you answer.
For complex tasks, ask the model to think step by step. This forces it to follow a methodical process, defining the problem, reasoning, verifying, and concluding, rather than jumping straight to a potentially incorrect answer.
In practice, this means moving from a direct question to one that requires a step-by-step calculation. This makes the model's reasoning transparent and auditable, which is vital for production workflows where accuracy is non-negotiable. Finally, technique 4 involves role and persona assignment. This can be one of the most striking ways to shift how the model processes your request. Technique 4 is role and persona assignment. By assigning a specific role, you shift the model's entire reasoning frame. A skeptical venture capitalist will focus on risks, while an enthusiastic startup advisor will highlight opportunities, even if the underlying facts remain identical. Role assignment is a high-bandwidth way to set a posture. When you define a sharp executive assistant, you immediately load defaults for brevity and precision. Your explicit constraints then refine that posture, rather than needing to build it from scratch. Technique 5 is structured output. If your goal is automation, unstructured prose is often problematic. You need a reliable, parsable format to pass data into other systems. The problem with prose is that it is brittle and hard to maintain. The solution is an explicit schema. By requesting JSON in your prompt and defining exact data types, you turn the model into a reliable, structured data producer.
Here is a working template for structured output. Note the instruction: no explanation, no markdown, only the JSON object. This eliminates the prose wrapping that usually breaks automated parsers, ensuring your downstream code receives exactly what it needs.
Technique 6 is iterative refinement. Always remember that your first output is just a draft. The goal is to reach high-quality results through targeted follow-ups. Do not rewrite from scratch when the first attempt misses the mark. Instead, treat it as a draft. Use targeted follow-ups to narrow the output. This leverages the full context of the previous turn and is far more efficient.
For a live demo structure, consider 3 rounds. Round 1 is your base prompt. Round 2 targets tone and specific details. Round 3 is the final polish for conciseness. This professional workflow produces results superior to a single perfect attempt approach. Rewriting from scratch is usually a trap. It discards the model's existing understanding of your domain and constraints. Refinement, however, is surgical, compounding, and helps you learn how the model interprets your specific tasks. This episode closes the gap between generic output and precision-engineered results. It shows how one task, when approached with these techniques, can yield vastly different outcomes. Compare a weak prompt to a strong one for the same task. The weak one is a generic request. The strong one specifies roles, audience, constraints, and exclusions. The difference is measurable, predictable, and intentional. When you count the constraints in a strong prompt, you see every phrase doing work, from setting the role to defining the focus area and using negative constraints. Every addition tightens the model's focus to your specific goal. Finally, we reach the habit that compounds all these techniques, building a personal prompt library. A prompt library is a curated collection of templates organized by task. It gains value with every use. By annotating what works and refining templates after each failure, you build an institutional asset of expertise that grows more powerful over time. Over months and years, your library evolves. You move from trial and error to using battle-tested templates. New tasks become easy because they rhyme with old ones, making your professional prompt engineering a true compounding advantage.
In this video, we outline the live demo structure you will see. We will demonstrate 6 core techniques: specificity, few-shot prompting, chain of thought, role assignment, structured JSON output, and iterative refinement. Each demo compares a basic approach against a refined professional prompt to highlight the performance gains.
You might wonder why these techniques grow more valuable over time. The reason is that as AI models become more capable, they can execute increasingly sophisticated and nuanced instructions. Consequently, better, more precise prompts lead to significantly higher quality results than ever before. This is the capability multiplier effect. It's a mistake to assume advanced models don't need careful prompting. In reality, skilled prompting acts as a multiplier on top of model capability, allowing the system to follow complex constraints and leverage deeper reasoning that simpler prompts cannot access. This episode treats prompt engineering as a structured engineering discipline. We move beyond simple tips to define techniques with measurable outcomes. Every demonstration provides a before and after comparison, so the real-world impact is visible, not just described. This table provides a snapshot of our core techniques, from specificity and constraints to few-shot examples, chain of thought, persona assignment, structured data extraction, and iterative refinement. Each method serves a distinct purpose and solves a specific common failure point in model output. Our goal for this video is straightforward. By the end of this session, you will be able to confidently apply all 6 techniques to your professional tasks, moving from basic interactions to precision-engineered results. Specifically, you will learn to construct robust few-shot sets, articulate reasoning for chain of thought, specify JSON schemas for automation, and build a personal prompt library that compounds in value over time.
Remember that these techniques are not meant to be used in isolation. They are designed to stack. A single, sophisticated, high-performance prompt can combine multiple techniques simultaneously, multiplying the effectiveness of your interaction with the model.
Coming up in episode 24, we will explore fine-tuning versus retrieval-augmented generation, or RAG. We will discuss when prompt engineering is not enough, how to choose between these 2 customization strategies, and the real-world costs of each. In summary, prompt engineering is a rigorous discipline, not a matter of luck. Use our 6 core techniques to boost model performance. Treat prompting as a capability multiplier and start building your personal prompt library today to lock in your professional gains.